So last week we stopped at data visualization, and this week we're going to pick it up from there. Data visualization is highly relevant to data mining. When you have a large set of data, you really need to utilize visualization tools to help you to understand the patterns and the processes. If you are planning to make data mining part of your career, you certainly want to take a couple of courses on data visualization or visual data analytics. You're going to find them to be really, really helpful. What is data visualization? Well, the phrase itself gives you a fairly clear definition. Data visualization is a graphic representation of large amount of information and data in order to provide insights into complex data sets. Through the visual display, it's easier for people to gather the key prominent features, interesting patterns in a more intuitive and meaningful way. In the literature, you're probably going to encounter the phrase data visualization and information visualization. There is little differences between the two. So we consider them these two the same concept. But I do want to differentiate those from scientific visualization and infographic. Scientific visualization, the key is to emphasize the realistic rendering of scientific data or processes. That will make it easier for students, scientists to understand the process and glean insights into those concepts or processes. We will look at one examples of scientific visualization. An infographic is a highly decorated graphic. The goal is to tell a story. Therefore, it has a higher level, a stronger level of subjectiveness, and the goal is to persuade a defined audience to get the message through. It's relatively speaking, they're very heavy on graphic design. So typical graphic designs not used in typical data visualization are often seen in infographics. So let's look at one example in each category. The first one we're going to look at is data visualization. This is one of the studies that collected bacteria from 222 healthy people, and the team create this visualization to show the invisible residents in our body. So as you can see, in the middle of this big circle, we see the family tree. Tree visualization is often used when the data has a hierarchical structure. So here, the entire world of microbes have this family tree starting from, this is a bacteria, this is archaea, and then from this we have phylums, and under phylums we can have class, family, genus, species, and all that. So therefore, you can see this tree is organized in a circular way. So all the branches can be visualized fairly clearly and precisely. And at the end tip, you see those black dots. If a tip has a black dot, this indicates this bacteria is disease-causing. So this graph, as you can see, carries lots of information. And then the middle layer of this circle shows you the location, the places within human body that those different kind of bacteria are found. So are they in ears, vagina, nose, tongue, or any other places? So those colors indicates where those bacteria were found. And then we have the color has actually, if you notice that they have different shades. Those different shades indicates the bacteria presence in what percentage of tested people. As you can see, many people have this bacteria in their ears, and this bacteria only appears in smaller number of people appear in their ears. And in the outer layer, those bars are abundance. This show how abundant each microbe is at its most common site. The longer bars shows the species that dominate this local environment. So this certain species dominates the tongue. And to what extent it dominates. So some bars are higher and some are lower. So you can see this presents an objective view of the data presented in a visual way that you can see fairly clearly and quite intuitively what branches, the microbes in which branches are found at which places. In contrast, a scientific visualization looks like this. It shows a simulation of a certain physical phenomena caused by mixing two fluids. So those colors indicates the movements when the two fluids are met. It gave you a visual and concrete impression how those two liquids mix. As we mentioned before, the accuracy, it's not decoration, it's not for anything, but it's to illustrate the process. An example of infographics is shown here. This depicts the Democratic and Republican way of thinking, how they look at the society, and the governments. As you can see, this graphic represents one view, maybe the main view, but certainly not all views. They try to highlight certain things and use certain aspects and used all kinds of graphic designs to convey the meaning. So in this class, we're going to scratch the very surface, the very top layer of data visualization. So we have mentioned the reason that we want to visualize data is to gain insight, because human brains, through the evolution that we just adapted to understand graphics better than understand text, for example. One picture was 1,000 words, remember? It allows us to search for patterns, help find interesting regions and suitable parameters for future quantitative analysis. It also provides a visual proof of computer representations derived. So this reminds me when you train, for example, a neural network, because it is largely a black box and it's hard for you to imagine what's going on there. You do, having a visualization to show how the parameters has been updated during the process will certainly be very, very helpful. when we visualize large set of data, I want to mention Schneiderman's mantra. Ben Schneiderman he is now retired, but he has been a prominent figure in data visualization. And his mantra is when you design any data visualization, you must have an overview of the entire data. Then you will allow people to zoom and filter, to filter and zoom into the interesting parts of the visualization and provide details on demand when user needs that. I think most of the effective data visualization applications is manifestation of Schneiderman's mantra. So I thought it's really worth the mentioning here. Because there are so many data visualization methods, the textbook provides a good way to categorize them. So we're going to look at the pixel-based visualization techniques, geometric projection techniques. The plots and charts that we have looked at it last week falls under this category. We use lines, dots, boxes to reflect the data distribution and patterns that might exist in the data. So those falling under the geometric projection visualization technique category. And we're also going to look at icon-based hierarchical visualization techniques and additional techniques that visualizing complex data and relations. Those are really mostly graphs. Virtual reality and augmented reality techniques that's being developed. I don't know if I have I don't think I have an example of those. Probably I will add those in the future. I'm going to stop here and start a new video to discuss the pixel-oriented visualization techniques.